Hi GOR, this is Unit 4, Lesson 3, and today we're going to talk about dilating lines and segments and rays. So in example 1, we have segment PQ, which we're going to put on the graph. So P has the point -3, 1, so we're going to plot that right here, P, and Q has the point 3, 2, and that's Q, right? And I'm going to connect them. And now I want to graph the image after a dilation from the origin with a scale factor of 3. So let me change up colors here. So I am taking P and I am dilating it with a scale factor of 3. So that means I'm going to multiply X by 3 and I get -9. And then I'm going to multiply Y by 3 and I get 3. And I'm going to do the same thing for Q. To get Q prime, I'm going to do 3 times 3, which is 9, and 2 times 3, which is 6. So now I'm going to graph P prime, which is -9, 3, right here, and Q prime, which is 9, 6. 1, 2, 3, 4, 5, 6. And then I will connect those together. Okay. Is the dilated segment still a segment? So the original segment was PQ in blue, and the new segment is P prime, Q prime in red. Is it still a segment? Absolutely. And what is the relationship between them? Well, if you look at them, if we actually used our slope formula, we would find that they are parallel to each other. Okay, they look parallel. They're not going to intersect. And it's 3 times the length. That it's because I multiplied by 3, but if I took out a ruler and measured PQ and I measured P prime Q prime, it would be 3 times as big. So here's the first concept. A dilation leaving a line passing through the center of dilation leaves it unchanged, and we're going to look at that right here. What happens if we dilate a line and the center of dilation is on the line? So in the one above, the center of dilation was the origin. The line segment moved further away from that origin. But if the center of dilation is on the line, like right here, you're going to get the exact same line. All right, so say that, let me get a thicker marker here. Say that AB, okay, was a line. Here's AB, all right, is a line. And I dilate it from point O, which is on the line. Then I'm just going to get another line on the same line. Okay, so if I have a line segment, or line rather, this is a line, so it does have arrows. If we dilate a line and the center of dilation is on the line, we get the exact same line. Change this. It's the same line. A dilation takes a line not passing through the center of dilation to a parallel line. All right, so that was like the example up above. So if I have a line right here, if AB is a line, that's my pre-image, and I'm dilating from point O, which is not on the line, I get another line that is parallel to it. Now a line goes on forever and ever, so it's not like the line is going to be twice as big or 3 times as big or anything like that. So those are the two concepts that we need to know for this unit. If I dilate a line from a point on the line, I get the exact same line. If I dilate a line from a point not on a line, I'm going to get a parallel line. All right. Let's look. Summary. The dilation of a line segment is longer or shorter in the ratio given by the scale factor. A dilation takes a line not passing through the center of dilation to a parallel line. A dilation of a line passing through the center of dilation leaves the line unchanged, meaning that it's going to be the exact same line. All right, so the questions that are generally asked on the Regents about this have to do with dilating actual lines on a graph. And we're going to just do a quick little review of graphing y equals mx plus b. So we learned that if you're dilating from a point not on a line, the new line is going to be parallel. Remember, parallel lines have the same slope. If you're dilating from a point on the line, then the line stays the same. So those are the two scenarios, but now we're going to do it on an actual graph. So if you remember back from graphing last year, y equals mx plus b. M is my slope, okay, and b is my y-intercept. And that's how I'm going to graph. So let's graph the line y equals negative 2x plus 3. M is my slope, so my slope is negative 2. B is my y-intercept, so my y-intercept is 3. And now I'm going to graph it. So the way I graph this is my y-intercept is my starting point. So I'm going to start at 3. I like my slope to be a fraction, so I'm going to put a 1 under there. The top number tells me to go up or down, and the bottom number tells me to go left or right. So since it's negative 2, I'm going to go down 2 to the right 1, down 2 to the right 1, and this is going to be my graph right here. Now let's graph and write the equation of the line y equals negative 2x plus 3 after a dilation of 2 from the origin. So remember, if I do a dilation, I'm going to get a parallel line. Parallel lines have the same slope. So I'm still going to have a slope of negative 2. My slope will be exactly the same. What's going to happen is that my y-intercept is the thing that's going to be changing. So keep the same slope because it's parallel. Take your y-intercept and multiply it by the scale factor. Okay, so I'm going to take that y-intercept of 3, and I'm doing a dilation of 2, so I'm going to multiply it by 2. So this is my new y-intercept. All right, so my new equation is going to have the same slope of negative 2, but it's going to have a new y-intercept of 6. So this is going to be the equation right here. All right, so the slope stays the same. The y-intercept gets multiplied by the scale factor. So this one is going to have a y-intercept of 6. The slope stays the same. It's going to be down 2 over 1, down 2 over 1, down 2 over 1. And you can see that this will be parallel. All right, when you dilate a line, and I'm dilating it from this point, the origin right there. So if you dilate a line from a point not on the line, you get a line that's parallel. The second situation is if you dilate a line from a point on the line. So look at C right here. Write the equation of the line y equals negative 2x plus 3 after a dilation of 2 from the point 1, 1. Well, let's look at what the point 1, 1 actually means. The point 1, 1 is actually right here on the line y equals negative 2x plus 3. And we learned on the first page that if you dilate a line from a point on the line, you just get the exact same line. So I'm not going to change my y-intercept. The slope is the same and the y-intercept's the same because it's the exact line. The point of dilation is on the line. So I have a little summary here for us. When you're dilating a line from the origin, you're going to get a parallel line. Parallel lines have the same slope. Multiply the y-intercept by the scale factor and leave the slope alone. That's the first situation. Second situation, when dilating a line from a point that's not the origin, okay, that point is always going to be on the line. We're supposed to check to see if the point lies on the line, but it always will be. And if it does, then the line stays the same. Okay? And that's it for today. We'll practice that tomorrow.